This lesson deals with supplemental problem 2.9. You can find this problem in the ECE201 ebook in the Chapter 2 Supplemental Problems on page 8. Suppose we're given this circuit and we're able to measure some of the voltages in the circuit. Can we solve for the remaining voltages? Okay, let's write down the values that we have here. So I've got 5 volts for V sub A, 7 volts for V sub B, minus 10 for V sub F, and 6 volts for V sub H. Now, if I can pick a loop where I know all but one voltage, then I could use Kirchhoff's voltage law to solve for that unknown. Let's try loop number 1. If we go around in a clockwise direction, we could take all of the rises in voltage and set them equal to the drops. So here's a drop of V sub A and a drop of V sub B. I'll put that on the right-hand side of the equation. There's a rise in voltage of V sub D. So V sub D is equal to V sub B plus V sub A. Now V sub B is 7 and V sub A is 5. V sub D here is equal to 12 volts. Now if I go around loop 2 here, say in a clockwise direction, I know all but one voltage. Let's do the same thing. So I'm going to go around the loop, take all of the rises in voltage and set them equal to the drops. So I have a drop of 12, I have a drop of minus 10, I have a rise of V sub G. So V sub G is going to be equal to 12 plus a minus 10, and that's 2 volts. Now if I go around loop 4, again I know 2 of the 3 variables, I can solve for the remaining one. Let's go around the loop again clockwise. I have a drop of V sub G, a drop of V sub H, and a rise of V sub E. So V sub E is equal to V sub G plus V sub H. In other words, 2 plus 6, or 8. So this is 8 volts. Lastly, if we go around loop 3 here, we know 2 of the 3 voltages, so we'll solve for the remaining one. Go around again in a clockwise fashion. So I have a rise in voltage of 7, a drop of 8, and a drop of V sub C. So 7 volts is equal to 8 volts plus V sub C. So V sub C is equal to minus 1 volt. And you can find the work for these calculations below. So here's our loop 1 result, our loop 2 result. We did loop 4 and then loop 3. And this is supplemental problem 2.9.